All right, based on the given information, knowing that the cosine of x is equal to negative 2/3. Remember, the whole negative positive side of these given values, that's always based on the quadrant. So for quadrant 2 here, all students take calculus, right? Sine and cosecant would be positive. It would make sense then that negative goes with the cosine part. Now, with all that in mind, the given trig value here of cosine allows us to set up a right triangle. Since it's the cosine of x that's given, I could let one of these angles be x. And since it's cosine, I could let the adjacent side be 2 and the hypotenuse be 3, right? Because cosine is adjacent over hypotenuse. Now on this triangle, I don't know what the opposite side is. So I probably need to create a little variable over there. Maybe I'll use a. Don't want to use x because x is my angle measure. If I let that be a and I solve for a, I'd use the Pythagorean theorem. Got 2 squared plus a squared equals 3 squared. Solving for a, well, let's see, 2 squared is 4. I'm going to subtract that over to 3 squared, which is 9. That'd be 5 when I subtract that over, equal to a squared. Taking the square root of each side. All right, I'm taking a square root, right? So there's always that plus or minus possibility that we got to be aware of. But since a represents a side measure, for the time being, I'm just going to throw a root 5 up here. As I consider other trig ratios, though, that might be useful to have, that plus or minus stuff, you know, keep that in the back of your minds because, hey, we are in quadrant 2. For instance, if I wanted to know what the sine of x was, now that I know the opposite side is root 5, well, I'd have root 5 over the hypotenuse, which is 3. That would be the sine of x. And that would be positive since we're in quadrant 2 because sine is always positive there. And I highlight sine of x because when you go back and you consider the formulas we have to find all this double angle stuff, I mean, look at what makes up these formulas. If you're going to figure out the sine of 2x, the cosine of 2x, and the tangent of 2x, we need to know things over here about sines and cosines, right? In fact, I know I've got tangent stuff down here, but really with the tangent stuff, the tangent of 2x, I could also find by putting the sine of 2x over the cosine of 2x, right? Because tangent is just sine over cosine. So long story short, on these types of problems, take the given trig value here, go ahead, set up a right triangle based on that trig value, but make sure that you have cosine and sine at your disposal. Okay, if you've got those two, then what you can do, just applying those double angle formulas, if I want to start by finding the sine of 2x, well, the sine of 2x as a double angle formula is 2 times the sine of x times the cosine of x. Since I know the sine of x is the square root of 5 times 3, I can insert that in after the 2, right? And the cosine of x, that was given. That was given as negative 2/3. I can insert that in here at the end. I multiply all that out, and I've got the sine of 2x. So this 2 would be over 1. Multiplying through the numerators here, you got 2 times negative 2, so negative 4. Got that root 5 that's just tagging along. 1 times 3 times 3, you got 9 in your denominator. The sine of 2x would be negative 4 root 5 over 9. All right, next we've got the cosine of 2x we want to find. As you go back and consider formulas for the cosine of 2x, you've got 3 that you can play with. Which one you want to use, completely up to you. We could use any of them now that we know what sine and cosine are. But if we went back to the very beginning and didn't have any of this work on this side, and we just knew what the cosine was, it would make the most sense to use this formula right here. Right? If we were only given cosine, we could just plug into that guy. So I'm going to go ahead and plug into that guy just in case I made a mistake on the first part, which is very unlikely. So that's going to be 2 cosine squared of x minus 1, right? Cosine of x is negative 2/3. Cosine of x is being squared. So when I plug this in, it's 2 times negative 2/3 squared minus 1. Just a matter of following some order of operations now. Starting with the exponents, we're going to square the fraction. We have 2 times, negative goes to positive. It's going to be 4 over 9 when we square numerator and denominator. This is 2 over 1, so if I do my multiplication next, you've got what? 8 over 9 minus 1. Common denominator of 9, this would be 9 over 9. 8 minus 9, negative 1. Denominator is 9, so negative 1/9 would be the cosine of 2x. All right, last thing we need to find, tangent of 2x. We've done a lot of work to get to this point, but really with the tangent of 2x, we can just use all that work to help us get this answer pretty quickly. The tangent 2x is just going to be the sine of 2x over the cosine of 2x. So for the sine of 2x, we found that that was negative 4 root 5 over 9. Substitute that in. Denominator here, cosine of 2x, we found that that was negative 1/9. So substitute that in. We plug in those values. We cancel out the negatives. We cancel out the 9s. We're left with 4 root 5 over 1, so our answer is just 4 root 5. All right, if we're going to find the exact value of the sine of 120, and we have to use a double angle formula, what I would do for starters, since it's sine, maybe I'd write out the formula as a point of reference for a double angle sine. It would be the sine of 2x equals 2 sine of x cosine of x. And then as I compare to what I'm trying to find here being the sine of 120, kind of line things up, this 2x corresponds to the 120, right? So off to the side here, I could take 2x on this type of problem. If it's a double angle formula, it's always going to be 2x. And I could set that equal to the angle that I'm plugging in, 120. If you solve for x, assuming we're doing these correctly, x should be an angle measure that you're awfully familiar with. This should be 30, 45, or 60. Once you know what x is, and you go back to your formula here, which is 2 sine of x cosine of x, we can plug in x as 60, and we've got 2 sine of 60 degrees cosine of 60 degrees. And the sine of 60 degrees and the cosine of 60 degrees are things that we can easily find. We can easily find these two items as long as we know our special right triangle for 30-60 stuff. I set that up as a quick reference. Opposite 30 is 1, hypotenuse 2, longer leg here, root 3. Everything revolving around 60 to find the sine of 60 and the cosine of 60 to plug in the formula. Let's see, opposite 60 is going to be the root 3, adjacent is going to be 1, hypotenuse is going to be 2, right? So it's 2 times the sine of 60. Sine of 60, opposite over hypotenuse, would be root 3 over 2. Cosine of 60, adjacent over hypotenuse. Adjacent's 1, hypotenuse 2. Everything's plugged into the formula. We go through and evaluate. That'll be 2 times root 3 times 1 on top, so it's 2 times root 3. Be 1 times 2 times 2 on the bottom, so 4 on the bottom. Got this 2 outside of the radical, which means that I could reduce this 2 and this 4. Factor of 2 goes into both. When the factor of 2 goes into both, we get root 3 over 2.